In this tape, I'd like to go over some assorted problems that might appear on the assessment test. It's just going to be a catch-all for problems that I haven't fit into any of the other tapes. So, miscellaneous problems. Very often there is a value problem on the assessment test. Something like this. Find the value in cents of N nickels and D dimes. To work this out, you have to realize that 1 nickel is worth 5 cents. And 1 dime is worth 10 cents. If I asked you how much were 3 nickels worth, 3 nickels are worth, you would say 3 times 5, or 15 cents. Similarly, 4 dimes are worth 4 times 10, or 40 cents. So if we're being asked about N nickels and D dimes, all we have to do is to multiply N nickels by 5 cents for each nickel, and D dimes by 10 cents for each dime. So the answer would be 5N plus 10D cents. And to say how the value in cents, you probably would just write 5N plus 10D, because they say it's in cents. Okay, each nickel is worth 5 pennies, and you multiply by the number of nickels. Each dime is worth 10 pennies, you multiply by the number of dimes. Let's try another one of these value problems. Find the value in dollars of R $5 bills and S $10 bills. Well, of course, one $5 bill is equivalent to $5. 2 $5 bills would be 2 times 5, or $10. Our $5 bills would be equivalent to 5 R dollars. One $10 bill is worth $10. 2 $10 bills, 2 times 10, $20. S $10 bills, S times 10, or 10S dollars. So 5R plus 10S dollars. Okay. Find the value in cents, or in pennies, of Q quarters and P pennies. Well, 1 quarter is equivalent to 25 cents. 2 quarters, 2 times 25 cents. Q quarters, Q times 25 cents. 1 penny is equivalent to 1 cent, 2 pennies, 2 cents, P pennies, P cents. So we have 25Q plus P cents. Okay, so you're now ready in case you get a value problem on your exam. Another type of problem that occurs are distance problems. In these, you have to make use of the fact that the distance that a car travels is equal to the rate at which it's traveling times the time that it's traveled, or the distance covered by a person or car or whatever. If it's going at a constant rate, r, you take the rate r, multiply by the time t you're traveling, and you get the distance. For example, you might have a question that says, if a car travels 40 miles per hour for 3 hours, it covers a distance of, and they give you a variety of choices. Okay, well, all we have to do is say we're going at 40 miles per hour. You can write it either miles per hour like that. Sometimes it's abbreviated mph. Or other times we write miles per hour as miles over hour, like that. 40 miles per hour, the rate at which it was traveling, times 3 hours. And we get that the distance is 40 miles per hour times 3 hours. 40 times 3, 120. The hours cancel, 120 miles covered in the 3 hours. 40 miles for each hour. You travel for three hours. We get 40 times 3, 120 miles covered. Let's try another distance problem. A car travels at 50 miles per hour for X hours. Express the distance it travels in miles. The distance is the rate it was going at, 50 miles per hour, times the amount of hours it was going at that rate, X hours. 50 miles per hour for X hours. The hours cancel, and we get that it traveled 50x miles. 50 times x miles. Let's try one more distance problem here. A car travels at 30 miles per hour for R hours and then at 50 miles per hour for S hours. Express the distance it travels in miles. So the distance is going to be the sum of the two distances traveled. It's going to be the first rate times the time you traveled the first rate for, plus the second rate times the time you were traveling the second rate for. Well, we first traveled at, the first rate was 30 miles per hour, and we traveled that for R hours. Plus, the second part of the trip, we were traveling at 50 miles per hour, And we did that for S hours. So here the hours cancel, and we have 30R. And here the hours cancel, and you have 50S. And they're both in terms of miles. 30R plus 50S miles. Aside from value and distance problems, it is possible to get any one of a number of word problems, just various applied problems that you could be asked. The best way is really just to go over a sample of these, and the more you practice, the better off you'll be. Let's try the first one. Tickets for a concert cost $5 if the expenses for the concert total $2,000. How many tickets must be sold in order to make a profit of $1,500? We're selling tickets for a concert. The concert costs $2,000 to put on. That's to get the entertainer, to rent the hall, what have you, to print the tickets. We have to figure out how many tickets we have to sell in order to make a profit of $1,500. Now, the money that we take in from selling the tickets, the income, minus what we pay out in expenses, will be equal to the profit. The income represents all the money we take in for selling the tickets. Less now, we take away the expenses, and that'll leave us with the profit. We want to know how many tickets must be sold. Okay, let's let X equal the number of tickets sold. We have to figure out what X has to be in order to get the profit that we want. Okay, well, if we sell one ticket, we get $5. Two tickets, we get $10. All we're doing is multiplying the number of tickets that we sell by $5 for each ticket. If we sell X tickets, we will bring in 5X dollars. As I said, one ticket, $5 is brought in, two tickets, $10, three tickets, $15. We are multiplying the number of tickets times the $5 per ticket. Okay, so that's what we'll bring in. Now, the expenses are fixed at $2,000. Okay, we want to make a profit of $1,500. So 5x minus 2,000 is equal to 1,500. We want to solve this simple equation for x. To solve for x, we're going to get x alone on one side of the equation. Let's add 2,000 to both sides. In order to do that, give us that 5x is equal to 3,500. And then to solve for x, we would divide both sides of this equation by 5, and then get that x is equal to 5 into 35 goes 7, so 700. So the answer, how many tickets must be sold? 700 tickets. And we can check that out. If we sell 700 tickets, we will bring in $3,500, 700 times 5. The $3,500 less the $2,000 for expenses will leave us with a profit of the $1,500, which is what we want. So the answer to this problem is we have to sell 700 tickets. Let's try another example now. A rope is cut into 2 pieces. If the original rope is 28 feet long, and if one piece is to be 3 times as long as the other, find the length of the longer piece. A rope is cut into 2 pieces. If the original rope is 28 feet long, and if one piece is to be 3 times as long as the other, find the length of the longer piece. We have this rope, and it's 28 feet long. Now we're going to cut it into 2 pieces, so that one piece should be 3 times as long as the other piece. Okay, let's let X represent the length in feet, number of feet in the length of the shorter piece. The length in feet of the shorter piece. And then, of course, the longer piece is 3 times that length. So 3x would be the length in feet of the longer piece. We're breaking this up. This is x feet long, and this is 3x feet long. We're going to cut the 28 feet, 2 pieces. One piece should be 3 times as long as the other. Since we don't know where to make the cut, we're calling that x. The other piece would be 3x. All right. Well, what do we know? We know that the longer piece plus the shorter piece together should be the entire rope, which was 28 feet long. So that x plus 3x should be equal to 28 feet. X plus 3x, the whole rope. The longer and the shorter piece together give you 28 feet. X plus 3x is 4x, is 28, and we divide by 4 to get that x is 7 feet. Now, be careful. Is that the answer to the problem? Remember, this is a multiple choice test, and even though we've done a lot of work, if you don't answer it correct now, you're going to be messed up for the test. It says find the length of the longer piece. In other words, x is 7 feet. That's the length of the shorter piece. 3 times x, that'll be 21 feet. That's the length of the longer piece. And together, the 7 and the 21, of course, gives us the 28. So we have the 2 pieces. One is 7 feet long, x. The other one is 3 times x, 21 feet long. 7 plus 21 together gives us the 28 feet. The answer to the problem, the length of the longer piece, the answer is 21 feet. They ask for the length of the longer piece. Okay, so don't lose credit by just being careless. Okay, let's try another problem. 10% of the 400 employees in a company are women. In order to have 50% women employees in the company. How many additional women should be hired? A lot, but the answer has to be a little more specific. 10% of the 400 employees in a company are women. We want to have 50% of the employees in the company to be women. How many additional women should be hired? Okay, now what we're looking for, of course, is how many additional women should be hired. So we're going to let X be that. Let X equal the number of additional women to be hired. Okay, now this problem is going to involve a proportion. First, we're going to figure out how many women are in the company right now. 10% of the 400 employees are women. Okay. How many women work for the company now? And the answer is 10% of 400, or 0.10 times 400, or 1/10 of the 400. So the answer is 40 women. How many women work for the company now? 40 women. Now, we're going to hire X more women. When we do that, we would like that the percentage of the women working for the company be 50%, that the total number of women working for the company divided by the total number of employees for the company should be 1/2. Okay, so after the hiring, we want the number of women working over the total number of employees to be 1/2. Or, of course, multiplying, we would like the number of women working to be 1/2 the total number of employees. We want 50% of the employees to be women. Or, as I said, you could say the number of women working should be 1/2 the total number of employees, whichever way you feel more comfortable. This is if I multiply both sides by the total number of employees. Now, how many women will be working after the hiring? Well, there's 40 right now, and after we hire X, we'll have 40 plus X working there. The 40 that were there plus the X more that we're going to hire. The total number of employees, well, right now there are 400 people working, but we're going to hire the X women, and of course they'll add on to the total number of employees. So 40 plus X, right now we have 40 women working out of the 400. In other words, only 1/10 of the people working are women. We're going to hire X new women. 40 plus X will be the amount of women working. 400 plus X will now be the amount of people working in the company. And we want 40 plus X over 400 plus X to be 1/2, or 40 plus X to be 1/2 of 400 plus X, however you want to work it. If we do it this way, that 40 plus X over 400 plus X is to be 1/2, we can then cross multiply, okay, to solve this equation. 40 plus X times 2, or 2 times 40 plus X, is equal to 400 plus X times 1. Okay, we've seen that we can solve fractional equations by cross-multiplying when we have only one fraction equal to another one. All right, now don't forget the distributive law. A times B plus C is A times B plus A times C. So 2 times 40, that's 80, plus 2 times x is equal to 400 plus x, and we want to solve for x. So we can subtract 80 from both sides of the equation. That'll give us that 2x is equal to 320 plus x, and now to solve for x, we'll subtract x from both sides of the equation, giving us x is 320. So 320 women should be hired, so that 1/2 of the total number of employees will be women. You see, right now, as I said, we had 40 women working out of the 400, and that fraction, of course, was 1/10. Now, if we add on 320, you will have then 40 plus 320. In other words, 320 employees that are being added are all women. 40 plus 320, that'll be 360. Women working out of the 400 plus 320, out of the 720 employees, and that will be 1/2. So we'll hire 320 women, and that'll change the fraction of women working from 1/10 to 1/2. Let's try another problem. A student receives grades of 85 and 87 on 2 exams. What grade must she receive on the final exam which counts as 2 tests? In order to finish the course. With a 90 average. Okay, she's taken 2 tests in class. She got an 85 and an 87. She's going into the final. She wants to know what she needs to get on the final, knowing that the final will count as 2 exams. Whereas the final will be 50% of her grade. The 2 tests going into the final are also the other 50%. And she wants to finish up the course with a 90 average. Okay, let X be the grade she must get on the final. Now, at the end of the term, say she gets X on the final, wants to figure out her average. To get the average, she'll take her grades, 85 plus 87 plus X plus X. So there'll be 4 grades, the 85, the 87, and whatever she gets in the final will count twice as 2 tests. So there are 4 grades. To find the average, she will add them up and, of course, divide by 4, and that has to come out to be 90. She adds up the 4 grades, the 85, the 87 that she got, the X that she's going to get, which will count twice. Add up the 4 grades, divide by 4, that has to be a 90. Okay? So, let's figure this out. 85 plus 87. 85 plus 87 gives us 172. So 172 plus 2x over 4 should be equal to 90. Now, let's multiply both sides by 4 to get rid of the fractions. We'll get 172 plus 2x, here the 4's cancel, equals 90 times 4, or 360. Subtracting 172 from both sides, 2x comes out to be equal to, now 10 take away 2 That's 8. 15 take away 7. That's 8. 2 take away 1 is 1. 2x is 188. And then divide both sides by 2. And we get that x is equal to 2 into 188. 2 9s are 18. 2 4s are 8. She needs a 94 to have a 90 average. She must receive a 94 to have a 90 average. Of course, anything higher than 94, she would have a higher than a 90 average. Okay, so the grade that she must get to get the 90 average is a 94. 94 or better will guarantee her at least a 90 average in the course. Basically, she had an 86 average going into the final, and with the 94 average, she'll wind up with a 90 at the end of the term. Okay, let's try another problem. A secretary earns $60 in 8 hours. At this rate of pay, how much will she earn in 12 hours? We're going to let x equal the amount she will earn in the 12 hours. And we're going to set up a proportion. The amount she earned is to the time she worked, as the amount she will earn is to the time she will work. The amount she earned is to the time she worked, as the amount she will earn is to the time she will work. Let's see what we have. She earned $60 for the 8 hours. The amount she will earn in 12 hours is X dollars. The time she will work, of course, is the 12 hours. Okay, $60 was earned in 8 hours. X dollars will be earned in 12 hours. Okay, we can multiply, well, the hours cancel out. We won't need them. The answer will be in dollars. We can cross multiply and get that 8x. So we have 60 over 8 as equals x over 12. We can cross multiply and get that 8x is 60 times 12. 8x is 60 times 12, 120, and then 60 indented, 720. And then dividing both sides by 8, we get that x is 8 into 720, 8 times 9, 72, 90. So she will earn $90 if she works the 12 hours. $60 in 8 hours means basically she's earning $30 for every 4-hour shift, and there will be 3 of those. She gets the $90 for the 12 hours. Okay, you can look at that while I erase the board. And then we're going to do one more problem on this tape. A baseball pitcher has played 25 games and has won 40% of them. How many games must he win in a row in order that he should finish winning 50% of his games? This is a simplified version of a more difficult problem. I realize he might play a few more games and lose some and win some others, and that might change it. He might be limited by the number of games he could play in the season, but let's just take the simplified version. Let us assume that somehow he's developed a terrific pitch, and from now on, the games that he's going to play, he's going to win, and he wants to finish off winning 50% of his games. And the question is, how many more games must he win in a row in order to do that? Okay, let x equal the number of games he must play and win in a row. He has already won 40% of the 25 games that he has played. Okay, which means he has won 25 times 0.40, 0, 0, 10 games. He's already won 10 games. Okay, when he finishes off, we want that the amount he won for the season over the amount he played to be 1/2. Or the amount he won, cross-multiplying, or multiplying both sides by the amount he played, the amount he won should be 1/2 of the amount he played. Now, the amount he won for the season will be the 10 he's already won plus the additional x that he's going to win in a row. He has played 25 games. The total he'll play will be the 25 he's played plus the x more that he's going to play. We're assuming that he's able to play and win x games in a row. So the amount he will have won at the end of the season will be the 10 he's already won plus the x more that he's going to win in a row. He's already played 25 games. Okay, with the x more in a row that he's playing, he will play 25 plus x. So we have 10 plus x over 25 plus x equals 1/2. 10 plus x over 25 plus x equals 1/2. We can solve this proportion by cross-multiplying. 2 times 10 plus x is equal to 1 times 25 plus x. Distributing the 2 times 10, that's 20. 2 times x, 2x, is equal to 25 plus x. I want to solve for x. I'm going to subtract 20 from both sides, giving us 2x equals 5 plus x, and then subtract x from both sides, giving us that x equals 5. So he must play and win in a row 5 more games to accomplish what he wants. let's look over here and see if he does that, then he will have won the 10 that he had, plus the new 5. He will have won 15 games. He will have played 25, and an additional 5, he will have played 30. So he will have, instead of winning 10 out of 25, which was 40%, he will have won 15 out of 30, or 50% of the games that he's played. And that brings us to the end of this tape.